This video follows the same structure as all my other What Is videos, but it's here to serve as a more in-depth stepping off point for some of you guys who might not have programmed before. Most of the other content on my channel is for people who already might know a language or two, but I don't want to exclude those who are just now getting into programming. I want to help you guys too. So here I'm going to explain fundamentally what is programming. So then you know what's possible with it, how it's done, and what to expect from any language, framework, or API you might encounter in the future. Also, this video will serve as a stepping off point to the rest of my What Is series. So if you watched this video and you enjoyed it, go ahead and check out any of the other ones on my channel. Now, the little introduction out of the way, let's get into the real video. So what exactly is programming? I know it's not very helpful, but I would define programming as the act of writing code. No duh. So code is, on a basic level, the instructions that humans write for computers to follow. Computers have CPUs, as you've probably heard of whenever you hear people talk about computers. And CPUs can make various calculations based on some given inputs. And one of these inputs is code, or the instructions that you pass to the CPU. So a CPU can run software, which is essentially an entire program worth of code or instructions, maybe like a game or something. And the CPU has this ability because it can follow any set of instructions you give it, as long as each individual instruction is specified within its machine code. A real computer with a CPU therefore has a lot more potential than something an embedded system, say like a calculator. Embedded systems cannot run any instruction set that you give it. They don't have a CPU. They essentially just run a given instruction set that some programmer hard-coded into it when they were building that device. So basically, you can tell a CPU to run Doom or Mario or any other program you want, but you can't tell a calculator to do that. Or at least, a dollar store calculator. Some higher end ones I'm sure have CPUs, but I would not care to buy one because they're pretty expensive. The takeaway from this is a CPU can follow any instructions you give it as long as you give it instructions it knows, and an embedded system only has a finite amount of instruction sets that comes with it. Now, the instructions that a CPU reads is in binary, which is just a bunch of ones and zeros. That's that sort of classical, all those ones and zeros you see in the background of like all those hacking images and stuff like that. Now, ones and zeros is the only thing a CPU can understand. And we like to think of them as ones and zeros, but at the hardware level, what's actually happening is voltage, electricity is traveling through the CPU. And this electricity is traveling either in series of high voltages or low voltages. It's sort of analogous to Morse code, where you have either a short beep or a long beep. Whereas here we have high voltage or low voltage. And as humans, we like to say ones and zeros. But in a CPU, it's essentially just voltage levels that's traveling through it. And different sequences of voltage levels can correspond to different instruction sets. So different manufacturers of different CPUs design their chips to understand different voltage sequences differently. And that means that every type of CPU has its own machine code or machine language. So 0101111 might mean something different on CPU A than it does on CPU B. Back in the early days of programming, humans actually used to write their programs in pure binary. And that would mean that they had to rewrite it once for every type of CPU they wanted to run their program on. Now, that was terrible. So eventually people got smart and invented the programming languages that we know today, the higher level languages. Nowadays, the languages that humans usually use range from C to Java to Python, and maybe a whole bunch of others that you might have heard of that are some fan favorites nowadays. Programs called compilers or interpreters look at this more high-level programming language that you've written. It goes through it to ensure that it follows a set of rules, which is the actual definition of that programming language. And if it all checks out and looks good, your code can get translated into binary. This now means that you can write all your code once and run it on all different types of machines. for the most part. There are some tricky things, like if one computer has a certain type of monitor and another computer has a different type, then, if you write code for monitor A, it might not necessarily run on monitor B. But those are usually very detailed things. For anyone who's just now getting into programming, you won't have to worry about that probably for a little while. So now that you know what programming is, how can it be used on a machine? The applications of different languages and machines vary a whole lot. I'll only be covering most of the widely used applications in this video. Different computers, as I said before, have different capabilities. For example, phones can make calls with special hardware, and the Wii can't. And different languages translate into instructions for using only some of those capabilities, usually. Most languages are designed for general use, which means you can access just about all of a general machine's capabilities through your code, but others only do certain tasks. So when you go to compile or interpret them, you can only translate them into a limited set of instructions on each machine. Every general use language lets you access, create, or change data on a machine, either from its short-term or long-term memory. This is one of the most basic models of computation, and is called a Turing machine. Every operation you can think of, creating, deleting, or moving files, doing math, moving pixel data to the screen, etc., can be done on a Turing machine. The way languages organize your code and information into things like functions, classes, and objects differs, but they're all Turing complete, which means they can all do everything a Turing machine can. Modern machines are a bit more advanced than the idea of a Turing machine because they have processes and a whole lot of other wacky stuff, so they can do more than one thing at a time. But I think I'll save multi-threading and parallelism and concurrency for a whole other video. This is just about the very basic stuff. So how do you start programming? Well, it's an easy concept. Just write your code in a file and run a compiler on it. If you wrote the code without breaking the rules set for that language, then it'll run on your machine. You may want to use other people's code to use bigger and cooler capabilities on your machine that you might not know how to do yourself, and that's fine. Doing this is called using a library, or module or package, depends on what the language wants to call it. A library is a set of code in a given language that someone else has already written that does something really crazy, like maybe it connects to the speakers on a computer and it tells it to make a sound, for example. So instead of you needing to write code that compiles to all those crazy instructions to do that, they've already written all the code that does that, and they gave a little name to that code, usually like a function or a set of functions, maybe a set of classes, and this is called an API. So you can very easily use the API of that library in your own code to run it, and by my example, have it produce a sound. As for actually writing and running your own code, there are a lot of tools that help you do this, usually depending on what specifically you want to write or run. Text editors help write code. IDEs, or integrated development environments, also help write and run code. Software development kits help compile and run code. They're usually used when you're working with technology from a very big company. So if you want to make an Android app, there is an Android SDK that will compile Java code into Android instructions. You'll also want to get comfortable using the command line or terminal. Using it opens a little window where you can directly type some shell scripts that gets run immediately. The exact script differs between operating systems. I'm on Ubuntu Linux, so personally my shell script is the Bash language. Unix systems use Bash as their shell script. So if you're on Mac or Linux, those are offshoots of Unix. If you're on Windows, unfortunately you're kind of out of luck because I don't have a Windows, I hardly know how it works, and I don't know what you would call that shell script. Okay, so now that I've gone through and rambled way too long about what programming is and how to do it, I'm going to give you a few basic demonstrations that ramp up in difficulty. Okay, so usually in any language, the very first program that people get taught is this timeless classic called Hello World. And for right now, I'm going to teach you guys Hello World in Python. Python is probably one of the easiest languages to get into just because it has so few rules that you have to watch out for when you're actually programming the language. It's not compiled, it's interpreted. And generally interpreted languages don't have to follow as many rules when you're typing it out as compiled languages do. So let's go ahead and type out hello world in Python. In Python, there's a function called print, and you just use it like this. So you have the function name and you have some parentheses. Now, print takes in what's known as an argument. Functions in languages can take in arguments. This is a little bit of data that you tell the function about, like an input, so that it'll give you an output depending on what you passed in. So we're going to say hello world. That's going to be our input. You see it has these double quotes. It's called a string. So it's basically just a bunch of text. It might be a sentence, or it might just be a word. It might even just be one character long, and a character being just one of these guys. You'll see strings used a whole lot in programming. They're used in almost every program. So now that I've written out a very basic program that calls a single function, I'm going to go ahead and run it. I have opened up my terminal here, and for those of you who don't know what the terminal is, I guess I'll also explain it here. So the terminal is what I was talking about earlier. It's the command prompt of your computer. Every command I type into here, you'll actually find in the Bash programming language. Imagine the file system on your computer. Like if you open up the File Explorer and you go clicking around, you'll see everything is in a folder, and you have folders within folders. On the Unix system especially, the sum of all the folders on your computer or laptop, they're all a big tree, right? You have some root, some very highest folder, and then you have every file on your computer falls somewhere within that folder, or within a folder that's within that folder, so on or so on. And a little word of expert advice, never mess in the root folder because you can cause irreparable damage to your computer. Trust me, I've done that before. So when we're in the command prompt, we can imagine ourselves as being physically within some folder in the file system. And if we want to know where, then we use the command pwd, which is print working directory. And our working directory is where we are in the file system. We can only be one place at once. So I'm in home Alexander. This is my home directory for my user on this computer. I think on Macs it would be /users/Alexander, if I remember correctly, but for Linux it's /home/Alexander. So let's actually go to a different directory. We can do this with cd or change directory, and I want to go to my desktop. That's pretty cool. Now I know where I am, but I forget what's around me. So I want to list with ls all the files in this directory. Okay, so we got a whole lot of stuff in here, but I want to cd into example real quick, because if I ls, you'll see this is my hello.py file, and that's the program I'm about to run. It's this one right here. So let's go ahead and run it. So in Bash, you can actually run every other programming language from this command prompt, and essentially you just have to name it. So there is some command on my computer called Python, and this refers to the actual interpreter that reads my code, makes sure that it qualifies as Python code, and then it'll run that code if it does qualify. So we're going to say hello.py, because that's the name of my file where all my code is. We're going to hit enter, and there we go. We got hello world. That's what the print statement does, is it displays text in the command prompt. It's pretty cool, isn't it? Okay, now I'm going to move on to something a bit more complex. I'm going to go to C, which for people who know how to program, this is definitely a big step up from Python. C is definitely one of the more complex languages. It's a lot closer to machine language than Python, for example, is. But I'm going to do something fairly simple in C, so I think you all will be able to follow along. So I'm going to add in a library in C, stdio. This stands for Standard input output. So if you want to use the print method in C, you're going to have to include this library here. Now in Python, what we found is we could just write a command like this and it'll get run. So generally programs will start at the top of your file and they'll go down line by line and run stuff in that order. Now in C, it sort of does this. You can create variables wherever you want in a file, or functions or whatever, but your code has what's called an entry point. So I'm going to create a function right here in C. This function is very special because it's called main. So in a lot of compiled languages, you have an entry point. In C, this entry point is called main. It's essentially a function that after your code gets compiled, it'll be compiled in such a way that when your programs run, it looks for main and it does all the code that you put inside this function first. So if you have any other function, maybe a function like int hello, whatever code's in here will not get called unless if you call the hello function from main or from some function that you call within main, or so on or so on. So you're going to have to call main first in C. That's just the way it works. And I actually don't want to do anything too complex, so I don't think I'll be creating any other functions in C. Instead, I think what I'll do is I'll create a for loop. And then I'll explain some more stuff about this function in a minute. Okay, so a for loop. Essentially, so imagine your compiler, it's going through your C code. So it starts up here, imports a library, it goes down here, there's nothing to do. It goes down here, you create a function. And so this function, when it's done, it gives you some integer. So you can call this function and it'll give you some number. Now in C, the return type, this number that you give from the main function, is the return code of the entire program. So if your program ran well without errors, just go ahead and return a 0 by default. And I'll do that after I explain the rest of this. Now you have int argc and char star argv, which looks alien and really weird, but it's actually simple, and these are some of the most useful arguments you will ever use in any programming language. So when I go and run this program, I can actually give it arguments like I would to a function. And I do that from the command line over here. So this Python program, I give it hello.py as an argument. So that way it knows which file specifically to go to. So the number of arguments you give to the file is defined by argc, and each argument can be accessed with argv. So a char in C is just one character. So if we go back to our string here, it might just be an H or an E, something like that, but just one character. So a star in C can mean something is a pointer, which I won't be getting into in this video, or it could also mean it's an array. So it's a group of characters together, which means it's a string, which is a group of characters in programming. And so you have a group of strings here. So what we have is a list of text values, and that is every single argument that we've passed into this program is what's defined by argv. And you know how many there are because you have argc. So that's pretty good. All that being said, I won't be passing any arguments into this program, so we can kind of just ignore these two. They don't really matter this time around. However, I do want it to return that 0 that I was talking about. So just put return 0 and a little semicolon. So now back to this for loop. As I said, you're going to go down here, 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 and then you get to here. What this for loop does is it defines some variable called a, sets its value to 0, and then it says, as long as a is less than 5, you're going to do all the code inside here. You're going to get to here. And then, yeah, if a is less than 5, then you're going to go from here all the way back up to here. You're going to make a increment. So if it was 0, it becomes 1. If it's 1, it becomes 2, so on and so on. And you're going to do this code again and repeat, repeat, repeat until this statement is false. So until a equals 5, or it's no longer less than 5. So let's go ahead and define something to do in here. I want to print out 3 zeros and then a new line. So a new line basically just means this in the command prompt. So you're going to see it's going to go down a line. Nothing much. So after this, I have something a little more complex to show you based on the same program. But for right now, I just want you guys to see what this is going to look like when we do it. So C is a compiled language, so we won't be using any sort of interpreter like we do with Python. Instead, we're going to say GCC, and we're going to see, what did I call this? I call it triangle.c. So we're going to say GCC, which stands for new C compiler. That's the compiler for C. Triangle.c, and do that. All right. It didn't give us any output, which means it worked correctly. So if we do ls now, you'll see we have this new file called a.out. So a compiler takes in a file in your C language or maybe Rust or some other compiled language, and it outputs another file that's pure machine code. So we can run that with // and a.out. Okay, and it printed out the 3 zeros, and it went to the new line, and it did that 5 times. Oh, I don't want to move that. Yeah, it did that 5 times, which is from 0 until it's less than 5. So 0, 1, 2, 3, and 4. But then when it gets to 5, it's no longer less than 5. So it'll stop printing this stuff out, and it just returns 0. And if you want to look at the return value of a function, in Bash there is a echo command, and there's a $? Function, which is the return value of the last program you just ran. So I'll just hit enter there. And yeah, the return value is 0, which generally means everything worked out okay. Now, I know I call it triangle.c, and there is no triangle in this program whatsoever. So I'm just going to change it a little bit so that way there actually will be a triangle. And I think you guys are going to like this. So I'm going to do a for loop inside a for loop because, yeah, you can do that. But I don't know where I want B to end up at just yet, so I'm not going to fill that in for right now. I do know I want to do this, right? And I'm going to change this. And yeah, I can use B here, right? Because when I create B here, it exists inside this loop, but it no longer exists after I get outside of it. And then this one recreates B. So they're different variables, but they're both called B at different times. Now, I don't want to call it A because then the compiler gets confused between this A, which still exists inside here, and this A, which exists inside here as well. So I'm going to choose a different variable for that. Most people like to use I or J or whatever. I like to start at A, go to B, stuff like that. And I'm going to copy paste this. I'm going to say printf new line. So what could I possibly be doing here? Well, I'll show you. Okay. So what we're going to do is, well, you'll see. So I'm going to go back and compile it again and do a.out. And well, it wasn't quite what I was hoping for, but yeah, we have a bit of a right triangle here. So it's a little confusing to look at it, and actually, you know what, let me just get rid of this. This doesn't change anything. Yeah, see, same thing. The only difference is that this has some extra white space on the side. See that? And this one doesn't. But to the human eye, it looks the same. So what exactly did I do to get a triangle out of this? Well, we're printing line by line, and then we go to a new line. And this outer loop, we've got 5. So we're going to print some number of white space and then some number 0 and go to the new line. So we should probably count this starting at the top and then going down. So let's walk through this program real quick, and then I'll probably wrap up the video because it's getting a little long. So we start at a = 0. That's fine. And then we look at b = 0. So while b is less than 5 minus a. So in this first iteration of the outer loop, it is, well, b is less than 5. And then we do some white space. So we put out 5 white spaces. And then we do b = 0 while b is less than a. Well, b is 0, a is 0. 0 is not less than 0, so we don't print out any zeros in this first line. And then we go to the next line, and then A is 1, so we want to do B is 0 till it's less than 4. We print out 4 white spaces, and then B is 0 less than 1. We print out 1, 0. And then each time we essentially decrement the number of white spaces we put out and increment the number of zeros we put out per line by line, and it ends up looking like a triangle, which is pretty cool. Okay, so where can you learn more about programming? Well, there are tons of books, websites, and other resources you can either rent, buy, or just look at online for free. Every language and framework, as well as a whole lot of libraries, have their own documentation sites. You can go and download code from these to learn how to use their surface level APIs. And documentation also lists all the functions and classes and whatnot in a language so that way you know how to use it. And in addition to all of that, you can also get help from other programmers on sites like Stack Overflow, or sometimes like programming groups on social media like Facebook. If you're new to programming or new to my channel, or you just liked watching the video anyway, thank you so much for watching. Hopefully you found the video helpful. If you did, please like, share, comment, subscribe, follow me on social media, click the notification bell down below so that way you never miss a new video, or you can also consider watching any of the other videos around the screen here. If you'd like to see a what is video on any particular technology or language or framework or whatever, just comment it in the comment section down below. Thank you all so much for watching, and I will see you guys next time.